Hi there, it's me again. So we're going to try to expand 7 cot of 7 theta using the Moivre theorem. So first thing we do is we need to find the binomial coefficients. So let's find the binomial coefficients. And the binomial coefficients are for this particular expansion, and because we're using the Moivre theorem, so we can rewrite this as cot from the Moivre theorem, we're going to say cos of theta plus I sine of theta and all of that to the power of n. Basically, our power n here is going to be power 7 because we have a 7 theta. All right, so this is like z to the power of 7. And we're going to expand this, but before we do the expansion, I'd like to talk about how we're going to expand this. Now, we can use the binomial calculations, the factorials and things like that, but that's going to be very complicated and very tedious because it's very time consuming, it's quite substantial. So we'd rather get the binomial coefficients ready, and this is going to make it a lot easier for us to expand such a complicated function. All right, so what we're going to do here, the binomial coefficients are 1, okay, and then I've got 7, 21, 35, 35, 21, 7, 1. Now you can get this by building your Pascal triangle, and when you reach the power 7, you're going to end up with these coefficients. Okay, so can we rewrite this? Because I want to expand cot of 7 theta, I can't do this straight away. So I'm going to start off with cos of theta plus I sine of theta power 7, and which can be rewritten as C for short, IS for short as well, 7. And now once we have this, and here we go, the C plus IS to the power of 7 can be equal to C to the power of 7, okay, plus the 7, okay, and then I, C to the power of 6, okay, and then S plus 21, and I've got I square this time, C to the power of 5, S to the square, plus now 35, okay, I to the cube, C power 4, S to the cube, plus 35 again, I to the power of 4, C to the power of 3, and then S power 4, plus, I've got now 21, okay, I power 5, C to the power of 2, S power 5, plus 7, okay, I to the power of 6, and then CS to the power of 6, plus finally I to the power of 7, S to the power of 7. Okay, so now that we've got our expansion, okay, we're going to use I square is equal to -1 to deal with the plus and minuses sign. So what I have is then cos of theta to the power of 7 plus the 7i cos power 6 theta sine of theta over here plus 21i square. Now we did say that I square is -1, so -1 times 21 is -21, okay, cos power 5 theta sine square theta, and this one is cube, so that becomes then minus 35i, okay, cos to the power of 4 theta, and then sine cube theta, okay, plus, now I power 4 is basically 1, because I square is -1, so I square times I square is -1 times -1, which is +1, so +1 times 35 cos cube of theta, and then sine power 4 of theta. This becomes then minus I power 5 is minus I, so minus 21i cos square theta sine power 5 theta. 7 power 6, 7 times I power 6. I power 6 is I squared times I squared and I squared. So that's negative 1, negative 1, negative 1. So basically we'll have negative 7, okay, cos of theta, and then sine power 6 theta plus, this becomes minus I, okay, sine power 7 theta. Right. Now, so where do we go from here? We are going to collect the real part and the imaginary part. The reason we do this is because we need them, because we have cot of 7 theta. And what is cot? Cotangent of theta is basically cos of theta divided by sine of theta. We know that cos of theta will be the real part and the sine of theta will be the imaginary part. So we're going to do that now. And so I'm going to collect, I can do it straight away, like, you know what I'm saying? So I'm going to take the real part, okay, over the imaginary part. The reason I do this is because I know that cot of 7 theta, let me just wipe this clean here. Cot of 7 theta is equal to cos of 7 theta divided by sine of 7 theta. And what am I saying? I'm saying that I'm going to take the real part over the imaginary part. So the real part are those terms that hasn't got I in them. So I've got the cos of cos to the 7 theta minus 21 cos to the 5 theta sine square theta. Then I've got 35 plus 35 cos cube theta sine to the 4 theta, okay, minus 7 cos theta, okay, and then sine to the 6, the power 6 theta. Now that's my real part. And all of that is going to be divided by the imaginary part. Now for the imaginary part, I've got I in them. So there's 7i cos to the 6 theta sine theta. So 7, okay, cos to the 6 theta sine theta. Then I have 35 minus 35 cos to the 4 theta sine cube of theta. I also got minus 21, okay, cos square theta sine to the 5 theta. Then I've got sine to the 7 minus sine to the power of 7 theta. Here's my real part over the imaginary part. Now how do we deal with this? We can see there's a sine power 7 here, and there's a cos power 7. If I take cos power 7 divided by sine power 7 throughout the whole expression, I'm going to end up with cos over sine, which is basically cotangent. Right, so let's do that. So I'm going to just write it down. So from here, I'm going to say divide top and bottom of this expression now here, which is top and bottom by sine power 7 theta. The numerator and the denominator. Okay, so now what is cot 7 over, cos 7, cos to the 7 over sine to the 7, that's going to be cot 7 theta, minus 21 cos 5, cos to the 5 theta sine square theta, and sine square theta over sine to the 7 theta, that means sine to the 5 theta. So we end up with minus 21 cot to the 5 theta. Then again, I've got 35. Okay, so it means plus 35 cos cube divided by sine to the 7, sine to the 4 over sine to the 7 is sine to the 3. So that means cos to the 3, sine to the 3 will end up as cot to the 3 theta, and then minus 7 cos over sine. Now cos over sine, here I've got sine to the 6, sine to the 7, that end up as sine in the denominator, so cos over sine is cot, so minus cot theta. Now divide all of that. Again, we're going to be doing the same thing. We're going to divide the numerator, every term in the numerator, by sine to the 7 theta. So here, 7 cos to the 6 times sine over sine to the 7, that ends up as 7 cot to the 6 theta minus 35 cot to the 4 theta minus 21 cos to the, so that means cot to the square theta. And then sine to the 7 over sine to the 7 is minus 1, basically. Now this is my cot of 7 theta. Now that has been expanded. Now if I were to, let's say now in the question, I remember there was something to the effect that if we have cot 7 theta is equal to 0, we can build an equation that can be solved to find the values of the unknown in that equation. The unknowns with s in that equation is going to be in terms of x. So what I'm going to do, I'm going to equate all of that to 0. So just write this down quickly. And as you know, the numerator here, it gets sent on, over to the other side. So 0 times the denominator times 0 is 0. So we end up with, and if we say let, let's say let cot of theta is equal to x, right? So I can say now cot to the 7 minus 21, cot to the 5 theta plus 35, 35 then cot to the cube theta minus 7 cot of theta is equal to 0. This denominator, it just disappears because it gets multiplied by 0 on the other side. Now, if I were to factorize this, I can divide the whole expression by cot of theta on both sides. If I were to do this, I divide this by cot of theta. Okay, that's going to end up as cot to the 6 theta minus 21 cot to the 4 theta plus 35 cot to the square theta minus 7 is equal to 0. And because we did say that cot theta could be substituted for x, now I end up with an equation x power 6 minus 24x power 4 plus 35x to the square minus 7 is equal to 0. Now here's a beautiful equation in powers of 6 that can be solved for this whole equation here. Okay, I might come up and solve this in a different video. Take care for now, or maybe in this video itself.